Title: Fine-tuning initial noise distribution with policy optimization for diffusion models. Abstract: This paper introduces a novel framework, fine-tuning initial noise distribution, FIND, which optimizes the initial noise distribution of diffusion models to enhance consistency between generated content and user input prompts. The authors propose formulating the entire optimization process as a one-step Markov decision process and employing policy gradients to optimize the initial distribution. A dynamic reward calibration module is introduced to predict the expected reward of the current initial distribution, guiding the optimization process. Additionally, a ratio clipping algorithm is proposed to reuse historical data and minimize the discrepancy between new and old policies. The paper demonstrates the effectiveness and efficiency of the proposed framework in both text-to-image and text-to-video tasks, surpassing state-of-the-art methods in consistency and speed. The main innovations include proposing an initial distribution optimization framework based on policy gradients, formulating the optimization as a one-step MDP, and introducing dynamic reward calibration and ratio clipping algorithms for accuracy and stability. Introduction. The paper discusses the limitations of large-scale pre-trained diffusion models in generating visual content that aligns with user input prompts. The authors observe that the initial noise distribution significantly impacts the final generated outcomes and propose adjusting it to align the generated content with user prompts without any training of the baseline model and extra network structures. The proposed FIND framework formulates the entire optimization process as a one-step Markov decision process and employs policy gradients to optimize the initial distribution. The authors introduce a dynamic reward calibration module to predict the expected reward of the current initial distribution, guiding the optimization process. A ratio clipping algorithm is also proposed to reuse historical data and minimize the discrepancy between new and old policies. Experiments demonstrate the effectiveness and efficiency of the proposed framework in both text-to-image and text-to-video tasks, surpassing state-of-the-art methods in consistency and speed. The source code will be released. Here is a combined summary of pages 3 and 4 of the research paper. The paper addresses the issue of limited control in text-to-image generation models, particularly diffusion models. Existing solutions involve fine-tuning techniques, conditional controls, and reward models to improve alignment between generated content and prompts. However, these approaches have limitations, such as high training costs and instability during the training process. The authors propose a novel method, FIND, which fine-tunes the initial noise distribution of diffusion models using policy optimization. This approach reduces computational overhead and improves stability during training. The method is based on the concept of policy gradients, which optimize the initial distribution of noise directly based on the reward function. The reward function measures the consistency between the generated content and the input prompt. The policy gradient is used to optimize the initial distribution, and a dynamic ratio clipping algorithm is employed to smooth the policy updates. This approach enables more precise control over the generated content through more accurate prompts. The paper also reviews the fundamentals of diffusion models, including the latent diffusion model and the denoising process. The optimization objective is to maximize the expected cumulative reward over trajectories, which are sampled according to the policy. The authors introduce the FIND formulation, which models the process of optimizing the initial distribution as a one-step Markov decision process. The policy is formulated as a Gaussian distribution, and the objective is to maximize the expected reward. The policy gradient is used to optimize the policy, and the method is illustrated in Figure 2. The paper also proposes a dynamic reward calibration module, DRCM, to address the issue of inaccurate reward values. The DRCM estimates the expected reward of the current initial distribution and adjusts the reward value accordingly. This module is essential for ensuring the accuracy of the optimization direction. The paper discusses the optimization of the initial noise distribution for diffusion models using policy optimization. The authors propose the ratio clipping algorithm, RCA, to enhance the optimization efficiency and generative performance. They demonstrate the effectiveness of their method through qualitative and quantitative experiments, comparing it with the baseline and state-of-the-art approaches. The results show significant improvements in terms of color accuracy, composition, and location in the generated images. The method also outperforms others in terms of computational cost, achieving approximately 13 times faster optimization. An ablation study further highlights the importance of the DRCM in preventing the network from optimizing in incorrect directions. Overall, the paper presents a novel approach that efficiently optimizes the initial noise distribution for diffusion models, leading to improved generative capabilities and efficiency. The research paper discusses the fine-tuning of initial noise distribution with policy optimization for diffusion models. It presents a novel approach that enhances the quality and consistency of generated images and videos. The authors demonstrate the effectiveness of their method through various experiments, including an ablation study and a user study. In the ablation study, removing the DRCM and RCA components leads to a decline in both image reward and aesthetic score metrics, highlighting their importance. The user study shows that the proposed method outperforms baseline models in terms of both appearance and alignment, with a significant preference for its text-image consistency. Additionally, the method is nearly 13 times faster than the baseline. The paper also explores the generalization of the approach to video diffusion, showcasing its versatility through a case study on text-to-video diffusion models. The results indicate improved text-video consistency, interframe consistency, and predicted user preferences compared to the baseline. Overall, the research presents a significant advancement in the field of diffusion models, offering a more efficient and effective approach to generating high-quality images and videos. The paper introduces FIND, a novel fine-tuning initial noise distribution with policy optimization framework, to align the content generated by diffusion models with user input prompts. Unlike previous methods that required extensive training or additional controls, FIND optimizes for any prompt within just 13 minutes. The authors observed that the initial noise significantly influences the final output of diffusion models, leading them to optimize the initial noise directly through the reward function using policy gradients. To ensure the optimization direction is not solely determined by the sign of the reward, they proposed the DRCM to predict the expected value of the reward under the current distribution. Additionally, they developed the RCA module to leverage past samples and ensure optimization stability. The authors demonstrated the effectiveness of their proposed method on various tasks, including text-to-image synthesis, image-to-image translation, and video generation. They showed that FIND can be applied to kinds of diffusion-based generative models, demonstrating its high generalizability and versatility. Extensive experiments and qualitative tests have proven the effectiveness of their proposed method. The paper also provides a comprehensive list of references, including recent works on diffusion models, text-to-image synthesis, and reinforcement learning. The authors also provide detailed derivations of their equations and additional examples of their method's capabilities on the drawbench dataset. Furthermore, they conducted an experiment on complex prompts to validate the effectiveness of their approach, demonstrating its ability to generate high-quality content while maintaining control. Overall, the paper presents a novel and effective framework for fine-tuning diffusion models with policy optimization, enabling the generation of high-quality content that aligns with user input prompts. The author's approach has the potential to significantly improve the controllability and versatility of diffusion-based generative models. The authors present a fine-tuning approach for diffusion models, optimizing the initial noise distribution with policy optimization. They demonstrate significant improvements in consistency and aesthetics compared to the baseline model and DPOK. The method achieves better performance in generating images that align with user-provided prompts. In the quantity evaluation, the authors employ the image reward and aesthetic score metrics to assess consistency and quality, respectively. They also report the total training time for the evaluation dataset. The results show that their method outperforms the baseline and DPOK in both metrics, while requiring less training time. The authors visualize the reward values sampled during the optimization process, observing an upward trend that slows down after 150 iterations. They set the number of optimization steps to 150, considering the time consumption. To validate the generalization performance of their method, the authors experiment with 3 custom models from the Civitai website, demonstrating the capability to optimize the initial distribution for different models and aligning generated images with prompts. The authors discuss the limitations of their method, noting that it treats diffusion models as a black box and is highly dependent on the baseline model's generative capability. They acknowledge that the method can only unlock the latent potential of large-scale pre-trained models and is limited by the reward function used. Future work involves experimenting with more baseline models, including Texto 3D and robot control, and using large language models as the reward model to achieve more precise control. The authors also provide sample images generated from draw bench prompts, showcasing the diversity and complexity of the generated images. The paper presents a novel approach to fine-tuning initial noise distributions in diffusion models using policy optimization, dubbed FIND. The authors demonstrate the effectiveness of FIND in generating high-quality images that match user-provided prompts. Figures 9 and 10 showcase the results of FIND, comparing them to baseline diffusion models and DPOK, a state-of-the-art method. The generated images exhibit diverse styles, compositions, and themes, ranging from surrealistic to photorealistic. For instance, Figure 9c depicts a teenage girl holding a book with a pink cover, partially obscuring her face, while Figure 10a presents a dystopian cyberpunk art-style image of a soldier. The results demonstrate FIND's ability to capture complex prompts, such as the concept of standing out from the crowd, Figure 9a, or a skincare product packaging with unique features, Figure 9b. The generated images also exhibit high levels of realism, as seen in Figure 10e, which displays an orange and dark orange snake. The author's approach leverages policy optimization to adapt the initial noise distribution, allowing the diffusion model to better capture the target prompt. This results in images that are not only visually appealing but also semantically consistent with the input prompt. The paper's contributions lie in the development of a novel fine-tuning strategy for diffusion models, which enables the generation of diverse and high-quality images that match user-provided prompts. The results demonstrate the potential of FIND for applications in computer vision, graphics, and artificial intelligence. The authors assume a diffusion model as the underlying generative model and utilize policy optimization to fine-tune the initial noise distribution. Future work may involve exploring alternative generative models and fine-tuning strategies to further improve the quality and diversity of generated images. The research paper discusses the fine-tuning of initial noise distribution using policy optimization for diffusion models. It presents a novel approach to improve the quality of generated images. The authors introduce the concept of Dream Shaper, which enables the creation of semi-realistic images from prompts. The paper showcases sample images generated using this method, including scenes of a dilapidated Japanese house flying in the sky, a person doing laundry, and a strawberry poster. These images demonstrate the capability of the Dream Shaper to produce detailed and realistic scenes. The authors also discuss the use of policy optimization to fine-tune the noise distribution, enhancing the overall quality of the generated images. The methodology is based on diffusion models, which are known for their ability to generate high-quality images. The paper concludes by highlighting the potential of this approach for generating realistic images and its applications in various fields.